Broadcasting now. So you get like how to compare this win on those.
Yeah.
Problems
Are there multiple ways to do the square though? I don't know. Negative half of b square.
Yep, that's
like the two.
Right.
True value or whatever.
True value. I don't remember that. I don't know that one.
Yeah, it's squared. So true value just means like it's positive.
Plus or minus? No, it's positive.
It's just the two straight lines on either side of it.
Oh, that was just a parentheses. Okay.
But it's squared anyway, so it's going to be positive no matter what.
Anyways.
So yeah, and then you just break it down to like x plus whatever squared.
Squared, yeah.
So now I was looking at, I gotta be refreshed on is the symmetric stuff.
oh, like the transformations and all.
So
2.3.
Yeah. I understand transformations. I gotta be refreshed on like even or odd. So that would be a question. Is that 10?
Yeah.
Yeah.
Let's go over a couple of those if we can.
Yeah.
So x to the fourth, that just looks like a squared looking thing, isn't it? Just the
Because you square root it. Yeah, and it's just x squared minus 9x.
So you just simplify that x squared minus 9x.
Yeah, to make it easier to deal with and to see the plot, you know.
I'm graphing that one. You have to like how do you graph that?
I don't remember. Do you remember, Julia?
I mean, the way that I would do it, because it's like x squared minus 9x. I think the way that you would do it is that you take negative 9 in that, like your origin, because you don't have any other, so it's just like 9, 0 or 0, 9 or whatever. But I mean, so it's like negative 9 is like one of the points, and then x squared still is like in front of that. So then it's just a 1 over 1. So. But like I said, graphing, like I can take the equation and I can like simplify it and everything, but then putting it onto the graph is.
I'm glad you just use a graphing calculator.
It works for me.
So y equals squared. A little boy, squared. Yeah, that's definitely not symmetric.
Yeah, because if it was symmetric, it'd be just like same thing, just like kind of like an open thing, you know?
Yeah,
It's not symmetric.
Not on the y-axis.
Well, then it's an odd relationship.
Or is it?
No, it's
Neither.
neither, isn't it? Because odd is reflected over the y in x-axis, right?
I gotta get some stuff on this. It's like the negative
Yeah.
of.
It's like the inverse.
Yeah,
or
so
whatever.
even it's just like the reflective like across the y,
Uh-huh.
and then odd is just like the reflective across the x and y.
Yeah, it's like
Yeah, it's good.
Yeah,
So
that's
neither, but can I see the graph?
yeah. So it's got the two parts that are coming through the origin and then through through 9. But I can't. So far down, I gotta expand my window. It's like that 20, negative 20. Still
it could just be going on infinitively.
Sorry, I did the X minimum instead of the Y minimum. Let's go to 20. Max 20. So it looks like. If you like complete the square on that or something,
To find all the information, to find the slope and HP.
yeah.
On which one?
X to the 4th power minus 9x squared.
Are you gonna close the square?
I don't know. I'm trying to figure out how you would figure out how to graph that thing.
Yeah. Are we sure that those are the same graphs? X to the 4th minus 9 squared?
I will get another one. It should be because it's just simplified. So it's X 4th. Plus 9. Wait a second.
So
Hold up.
what did x to the 4th minus 9 times look like?
It looks like it is.
It looks like a parabola.
No. It's like
Oh, it's like the crazy little
yeah,
W.
W.
Oh.
So that one is symmetric.
But it's a different graph.
Yeah. That's fun to use. I guess you could throw it in when at the origin. You go 0, 0, x equals 0, y equals 0.
Mm-hmm. I guess yeah, you could just throw in the points like or x is 1 and that just be -8. Right? It's below the x-axis 1.
Y is negative 8. X is -1. Y is -8.
If you do -1, it'll still be -8. Oh, it is symmetric.
Yeah, it's even.
If you do -3.
We saw it on a graphing calculator or something.
We're allowed to use a calculator for an exam.
I think so.
I
Graphing calculator. Better. So I'm getting another 0.
Right?
Can't use a freaking calculator in a math exam.
Right.
I'm out. Okay.
Okay.
But yeah, I mean, it is saying you don't want to graph. You got to determine whether graph each function is symmetric with respect to the y-axis. So
I'm trying to find like in the book and seeing if it's like if there's any tips or anything to like figure out just like by looking at an equation to see if it's
Yeah. Your graphic calculator was a W?
yeah.
X.
So it came down,
-9x squared.
and then at the top of the parabola came down as you had the origin. It came back down and up.
then probably only went down to -9, didn't it?
How far did it go down? I'm trying to.
So yeah.
Oh, whoops.
Down past 9. -20.
Oh. Okay.
-20.
So it's just kind of like in order to find like the change of it and then everything, we put x and set it with -x. And if we come out with the opposite, then it's odd.
So we go like 2x. That's 2. 16.
So like we take like the -x to the 4th, and then we take the negative of 9x squared. So then it becomes -x to the 4th plus 9x squared. And
Wait, what?
so replace x by -x in the formula or the function and simplify.
Okay.
And if the function of -x is equal to the f of positive x, or like just the opposite, it's an odd function. And the graph is symmetric about the origin, or just maybe it's odd. Since because the negative, and then if it's like the -x is equal to the positive x, function is even and symmetric. But if it does not, if it's not like opposite of each other, the function is neither even or odd and does not have any type of symmetry. So it's like C, I guess. So we take, so the negative stays in front, and we just submit the x with the -x. and then
got
plus
X
1.
plus 1.
And then, since it's positive x, still plus 1, it's not the same. It doesn't equal each other, so then there's no symmetry for C.
Okay.
Because it's not like x minus 1.
Yeah.
We needed to get x minus 1 for it to be a symmetrical one.
So for B, that would be x cubed plus 5x.
No, so you would it would go, the x itself becomes a negative x. So there's a negative in front of the negative x and it's still cubed. And then it goes into minus 5 is being multiplied by a negative x.
Okay, so write it out. It's negative parentheses negative x cubed
Minus 5.
minus 5 parentheses negative x.
Yeah, so I guess it still becomes positive 5x.
Yeah.
I guess I was just doing it
So it'd be
online.
positive x cubed plus 5x.
Yeah.
So I'm gonna get odd, right?
Yeah. Because it's
When negative x. Save for calculus.
the explanations in the book in like section 2.3, and it's in example 8 determining symmetry in a graph. So you can practice that. But that's the idea: is you submit or you substitute x for negative x.
It's 2.3.
So then, yes, the cubed, if we put in negative x for that one, and then minus 9 by negative x squared, 9, the 9 is still negative, but the x is positive. It doesn't affect the negativity of the 9 being squared. And then the x is included.
So it's just equals the exact same thing.
Yeah,
You take
equals the
negative
exact
x,
same thing.
so make it even.
As far as my understanding, yes.
Okay, we're getting somewhere. I just gotta figure out how to understand the odd. So B would be odd. Is that right?
B would be, yes.
And then C, where it would change the x, it wouldn't affect the 1.
Where it doesn't equal the like the opposite.
Yeah, it'd equal thing.
It's not symmetrical.
Okay. Getting it. You with us?
Kind of.
I'm just barely getting
it. So A is symmetrical and even, right?
Right.
B is
odd.
And C is neither.
Mm-hmm.
So we were going to see what the graph of B looks like real quick. Negative x cubed minus x. Okay, so that's the graph of it.
Yeah.
So it's not exactly straight line, it's kind of a
Yeah,
That.
it's like the cubed stuff.
I'm trying to like envision how to flip it again, because it's symmetric.
For the odd.
For odd.
Yeah.
Yeah, so you have, or to make it same. Yeah, you gotta flip twice.
Yeah.
Okay. Okay.
So,
Graph of B is from left to right descending over that origin 0. Okay, cool.
Yeah, so it's kind of it looks like a straight line, but it's kind of
Right.
that. So in order to,
Little S weird thing.
yeah, in order
Yeah,
to
the cubes.
symmetricate it, you gotta flip it and flip it again.
okay.
So then it's not an S going this way, but it's an S going this way.
Do they want you to do that?
Well, that's just like what we're trying to prove is the symmetrical over the y-axis and the x and everything. And since odd has to be flipped twice in order to be symmetrical, that's just the proof of it. Does that make sense? That's just the explanation.
Oh, okay.
Graph.
Oh, yes.
So that's like mirrored of each other over the y.
So
So
it is odd,
odd,
but it's not symmetrical. Right?
right?
Because
Symmetrical would be
across the y-axis.
Yeah, symmetrical. I mean, it's actually not the same thing. I'm just saying like it's like a parabola.
Right. Okay.
okay.
And then C
Is neither.
It's just
C would be a
be like a line.
line through that one. Yeah, it'd be like a the y-intercept being just 1, and if the y-intercept is 1,
And the slope is like 1, and it'll just go.
it can't be symmetric anymore. Okay. I think we got it. I think so. Functions, I don't really have too much with functions.
No, I was just.
Functions that are 1 to 1.
Mm-hmm.
What's the definition of that again?
Yeah. No, I just need more practice, obviously.
Functions that are 1 to 1. Or is that 2.4?
Yeah, or 2.5.
2.5.
If it's 1 to 1, that means it can be inverted. Right? How do we know it can't be inverted?
Well, if it doesn't equal 1.
Right. Let's do one of those.
Which one would you like? On the extension, one of the extension problems are function, and it says to find the inverse. So give the definition of like the. Oh, well, that would be a little difficult. That's something different. Oh, but 3 is find the inverse function of that function on the extension problem. So it's the function is 2x plus 1 over 3x minus 4, and we have to find the inverse of that.
X plus 1 over 3x plus 4.
2x plus 1 over 3x minus 4.
Minus 4. Okay. And the inverse. So we got y equals 2x plus 1, 3x minus 4. X equals.
Which one are you doing?
It's on the extension problems.
The extension problem number 3. Wait, don't you just substitute y for the x's?
Yeah.
For the inverse. Oh,
I'm just going to go over all the steps they told you. So the first, you substitute f of x for y, and then you substitute y in for x. So you get x equals 2y plus 1 over 3y minus 4.
Oh, extension for 2. Sorry.
Here it is. And we got
Which problem?
3.
find the inverse of the function 2x plus 1 over 3x minus 4.
3xy minus 4x equals 2y plus 1.
Do we have to turn in extension problems?
No. These are just extension problems to work together on the little video.
So number 3.
3xy, then you just kind of flip-flop the 4x and the 2y. So you make it 3xy minus 2y equals 4x plus 1. I'll factor out the y. Equals. So it just always switches the lower variable, not lower, the lower integer, and the first number next to x. So the regular problem is 2x plus 1 over 3x minus 4, and then the inverse is 4x plus 1 over 3x minus 2. I always just flip those, but I don't want to rely on that.
4x plus 1.
Yeah, over 3x minus 2 is what I got for the inverse.
Yep, that's what I got.
You didn't get that. Got close to that, but I didn't get 4x plus 1.
What did you get? The 1 should never move from the right side.
Right.
So I multiplied each side by 3y minus 4.
Yeah.
And then I got 3xy minus 4x equals 2y plus 1.
Yeah.
And then 3xy minus 2y.
Yeah.
Subtracting 2y from both sides.
Mm-hmm.
And adding 4x to both sides.
Mm-hmm.
Oh. Okay. So.
And then you factor out the y, because you have all the y's on the same side.
Right, so then I just get mixed up by the plus and minus. 3x minus 2. So y equals 1 plus 4x over 3x minus 2.
Mm-hmm.
So I think this is where I was having trouble when you throw it back into the equation. You got like 2 parentheses. When you try to find out if it's really the inverse.
Oh, so check it.
Oh
yeah. 2 4x.
You
plus
do
1.
f of x and the inverse of x, and if you get the same thing, yeah, it's tricky stuff.
Yeah, that's where I have problems is like this fraction parentheses over another fraction parentheses. 3x minus 2 plus 1 over 3.
The inverse of 2.
Yeah, fractions over fractions over fractions over fractions.
Yeah, it freaking sucks.
So you guys, you'd have
Um,
2 times 1 plus 4x over 3x minus 2 plus 1 over 3 times 1 plus 4x over 3x minus 2 minus 2.
No, minus 4. Because it's from the original.
Oh, I'm doing the inverse into the original.
Yeah, I mean, your top sounded right. 2 by 4x plus 1 over 3x minus 2 in parentheses plus 1 over 3 by 4x plus 1 over 3x minus 2 minus 4. Like in parentheses minus 4.
Oh, minus 4, you're right, sorry. Yeah, minus 4. I thought you meant in the parentheses.
No.
And you have like 8x plus 2 over 3x minus 2 plus 1.
Yeah, I would factor that in. And 12x.
Wait, what?
3x minus 2. When you simplify that, can't you?
Sure you can.
So you have like 4x plus 3 over x minus 2. Or
Wait. So 6. 8 minus 6 is 2x. And then it's just minus 1. Do you see what I did? Did you see what I did? So I took like the fraction. So on the top, we factored in the 2. We got 8x plus 2 over 6x minus 2 plus 1.
does the 2 affect both? Or does it just affect the top?
It just affects the top part because on the bottom it's being multiplied by 3.
I mean, like, when you multiply 2 times 4x plus 1 over 3x minus 2, would it just be like 2 over 1 times 4x?
No, it affects the denominator and the numerator.
It does?
Mhm.
Okay.
Because for 1 to be 1, or like for 2, like to be equal and like to be 1, it's 2 over 2. Not 2 over 1. Just think of like 1/2, you have 1 over 2.
Mhm.
For that to be a whole, it's 2 over 2. And for like 1/3, it's 1 over 3.
Yeah.
But for that third to be a whole, it's a 3 over 3 to be 1.
Yeah, but
Oh,
this
but
is
it's
2. So it's 2 over 1.
Yeah.
So
I think I just like. I think on the quiz, I just. When something similar happened, it was like 2 times fraction over fraction minus 2. I think I just like canceled one out.
Yeah,
Is that what you guys are doing?
kind of.
That might have been where we got dark points. Just because I don't know if that was like the correct way to simplify.
So after the
Basically, like this one, it's just the fraction.
The fraction,
plus
that's the fraction.
Two
Two
times
times
the
the
fraction. It's the same as the fraction.
Yeah.
So there's 2 fractions over 3
for
fractions.
3 fractions.
So like
So like
so
you just like
get
the
2
2
on
by the top.
Is that equal?
Wait, say that again. I'm fixing my work. Sorry.
So
So
2.
so we got 2 times
the inverse
Right.
plus 1 over 3 times the inverse minus 4.
Yes.
That's
That's basically
2 of the inverse is plus an inverse.
Yes.
Over
an inverse plus an inverse plus an inverse.
I wrote it down.
So
I got like
wrote
wrote it out right here. So it's 2 of the inverse. Is it backward?
Backward?
No.
I
I can't tell.
I got x plus 2 over 3x minus 2 plus 1.
I didn't do that.
And then 12x plus 3 over 3x minus 2 minus 4.
Yes.
Yeah.
But I see what you're saying. Like you cancel out the denominators.
Right.
So they're the exact same.
Right. So like the 2 and 2 is just plus 1. Well,
So you just-
sorry, minus 1.
So you just skip a step. Because what they had to do in the book is like you just multiply them. So you flip it.
See, no, that's just
That was the book, and so I was like,
What did they do in the book?
so they do because it's a fraction divided by a fraction, so
Uh-huh.
they just split the one fraction so they can multiply it.
Yeah.
And so that numerator, that denominator just cancels each other out.
Yeah.
And so it's just 8x plus 2 over 12x plus 3.
Yeah.
I guess I just better do the way you guys do it. I don't take my ways.
Well, for example, if we had like 8 over 4.
I gotta put the 2 into it, so it's 2 plus 8x over 6. Okay. What did you guys do?
So we just so it's 2 parentheses in that fraction.
Yeah.
So you just multiply 2 times the numerator.
So then it becomes 8x.
Oh, okay. 1
plus 2.
plus 4x, right? No?
So multiply that by 2.
2 plus 8x over 3x minus 2.
Yes.
Gotcha.
Plus 1.
Plus
And then
one.
over 3 by 4x plus 1 over 3x minus 2.
So 3 plus 12x over 3x minus 2 minus 4.
You can mix up because you have like the
You have like
single digit in
a
front of it.
yeah.
Yeah.
Okay, we're good. Yeah, you got it right. Now,
And then how do you find it there?
like I said, I think we just cancel out the denominators because they're the exact same on that. So the 3x minus 2 is canceled out on both. So it becomes
2 plus 8x plus 1 over
What do
3
you-
plus 12x minus 4, is that what you're saying?
yeah. What do we do with these numbers off to the side?
Well, so you can, since we know that 1 is 1 over 1, you can put the 1 on top on the numerator, so then it becomes 8x plus 2 plus 1
3x plus 3.
over 3x minus 2, you know? And then, so it looks like 8x minus 2 plus 1 over 3x minus 2, and then multiply that by the opposite, so 3x minus 2 over 12x plus 3 minus 4.
I basically what I was thinking is just kind of skipping that step and just canceling out the denominators.
Yeah.
So it becomes 8x plus 2 plus 1 over 12x plus 3 minus 4.
Right.
So you just go 8x plus 3 over 12x minus 1.
Great.
Minus 1.
For the two
Yeah,
watch
it's
this
minus
thing.
1.
Okay, so then we do the other one.
You just gonna watch this thing like you got way too many steps in this thing.
So to prove it, you have to do the other one, right? You have to put the original into the inverse. And if you get the same thing, right?
Yeah, we just simplify that into equaling not that. Why? What did we do wrong? Didn't go right.
I don't know. I usually just get the inverse and I forget checking.
Yeah, me too. So can you simplify the 8x over 12x?
Yeah, to, what is it?
2x over 3x.
Yeah.
2x plus 3 over 3x minus 1. But the original is 2x plus 1 over 3x minus 4. So that means not in inverse?
No, so it's the same as the original. So you would plug the inverse into the original, and then you plug the original into the inverse. If you get the same thing both times, then it's
So you have to do it both ways.
That sucks.
We're just not throwing the extra step and doing it the opposite. Oh my gosh. Okay.
Okay, we gotta do this again. My computer
But
just
the other way around. Okay. Well then.
That's why I just canceled out, but I don't think she liked it. I don't think it was wrong,
but I
wanted
wanted
it the right way. But
Yeah. Holy Hannah. Alright.
So
We're done. Conquest.
So now we gotta take the inverse and then plug the original into the inverse.
Yeah.
Correct.
So then 4 by 2x plus 1 over 3x minus 4. Alright guys. Let's do it.
Okay. So we got 4 parentheses 2x plus 1.
Oh, you already done?
Math is plus 1 over 3 times 2x plus 1 over 3x 4 times 2. Okay. Now it is a lot faster.
yeah, 1 plus 8x plus 1 over 3x. No, not 8x. Sorry. That's why I probably didn't get it right.
3, 4, 2. Cancel those. We got 8x plus 5 over 6x plus 1. You suck again.
No, it's not.
It doesn't work.
So
So I got 3x.
yeah, the inverse is wrong, or we did
Or we
something
just
wrong.
suck. 4x plus 5 over 3x plus 1.
I was not sure on everything, but my way.
Something screwy.
Okay, wait. So find the inverse. All right. Well,
I did all that work for it not to be correct. Wait a second. Why did I wrote that thing totally wrong.
what?
Hold up. Yeah. That.
Oh, shoot.
Times 2 plus. Is that not a nice one?
Hmm.
Okay. let's add it. So I have 2x plus 3 over 3x plus 1. One second.
You have what?
2x plus 3 over 3x plus 1.
How
The
do you?
second one, but the first one we got 2x plus 3 over 3x minus 1.
Yeah.
What? Zeros. So it's not inverse.
Guess not.
Unless we suck. Which is a very good possibility. Did you get that though? The 2x plus 3 or 3x plus 1?
Yeah, I found what I did wrong.
Yeah, I
To
put,
get
for some
that.
reason I did 4. For some reason I did 4. That's 2x plus 1. Minus 4 plus 1 plus 1. Instead of doing that 2. But yeah.
Find the inverse, and we ended up not finding the inverse. Don't get it. Don't get it.
It's uninversable. No, I did that wrong, but yeah,
Yeah, this isn't guys.
I did it right the first time. So okay, so what are you not inverse?
That's not the inverse.
Yeah. Unless you found it.
Might be close.
So that's a freaking inverse. I don't know what I'm doing. It's uninvertible.
Do some functions just not have an inverse?
Yeah, there are functions that are not.
Inversely related.
Because basically, I got. This is going to be kind of different. I got. I don't think. Yeah.
Oh,
determine whether the function is
is invertible, so it's not.
So after all that, the answer is just no.
Yes.
All right, well, let's move on.
Okay.
Are you supposed to leave at 11?
Yeah.
I didn't realize that. It was already almost 11:30. Oh, freak, my wife's got to go in like.
Well, keep trucking on.
Yeah. What's like the goal for this GHOA? Just to make sure we understand crap.
I think it's kind of nice. You guys help me understand stuff.
I don't feel like I understand anything.
I don't
After that
anything either.
stuff right there.
I'm lost in my mind. I'm like going crazy. I'm like, wait. Hold up.
We did it like multiple ways, and I didn't. Yeah, we did. We figured it out.
Yeah, I hope so. Watch us get some like feedback on this video. Like, you guys are idiots. Totally was the inverse.
Read the book. Yay.
Have a good day.
See you, man.
Awesome.
See you Friday morning.
Friday morning.
I guess.
Jeez, you can just walk around it. It's our new
You
Keurig.
got a coffee maker?
Yeah.
You want me to close the door?
Yeah. No, you can leave it open.
Yeah, I realized how close you lived to my house. You're like right around the corner. That's nice.
See you
All right,
guys.
see ya.
Bye.
Okay.
That's awesome.
That was terrible.
Awesome. Okay. So
We should do one more of those things just to,
you want to find another verse?
yeah, just to be sure that we're not getting them all wrong.
Okay. So
Let's do one of those from the practice exam. Unless there's another one. Yeah. So let's do.
yeah. There's no other ones on the extension. The determine whether each function is invertible. If the function is invertible, then find the inverse function and state the domain and range of the inverse function.
Wait, so you're able to switch over to determine if it's invertible before you even run it out?
I guess so.
What the junk? I know there is a way, but I forgot it. So I learned it in college algebra. I'm sure it's going to show up in later chapters.
Yeah.
Like, hey guys,
For real.
this is actually easy. But so you want to try doing C?
Sure.
X minus 7 over x plus 5. X equals y minus 7. 5 x y x y y y equals minus x plus 7. Y times x minus 1 equals either 5x minus 7 over x minus 1.
5x minus 7 over x minus 1.
Okay, negative 5x.
Negative? Oh, yeah. No. I just forgot to put that down in my final.
Okay, so let's run through equation again. Just, I want to make sure that we understand like how to do that part of it. Otherwise, let's just do another one that's not invertible.
Right. Right.
Okay. One, 7.
Holy crap.
How do you feel with 1, doesn't it? 1 minus 7.
No, hold on. That one goes away. That goes away. That goes away. So then it's just 7 over 5.
Does it go away or does it equal 1?
Well, they cancel each other out. So it's like you're canceling out x minus 1 because you flip the denominator and the numerator and everything and you multiply it. But also, we can also see that there's a negative 5x and a negative 7 as well. So then all that we're left with is an extra negative 7 and a plus 5.
Wouldn't that still, so if you did that like by itself, so say you have like 3 over 4 times 4 thirds,
Yeah. Well, I guess that would be 1.
that's 1.
Right.
So we got 1 minus 7.
Or is it 2? Yeah. No, yeah. Mm-hmm. Which is 1. Wait, no, it's negative 1. Like the final answer. Hey! Isn't the function supposed to equal 1? Like if it's inversely and everything? So if the function is equal to 1, but the inverse function is negative 1, well then we figured it out.
That's correct.
Boom! Curtis, you better be watching this later. Yeah, that's what's supposed to happen. Yes. Okay.
Yeah, so it's
Because if f of x is equal to 1,
yeah.
the inverse function, so
Where's
like
that?
a function of negative x is equal to negative 1.
That's how it's supposed to be.
Of course, in the book, I can find that explanation and everything. But ugh.
What is that? Is that 2 point?
Like 2.4, 2.5, something like that. I'm going
2.5.
Well, 2.5 doesn't even give much explanation, as I found out. Or at least the explanation that we're looking for.
Yeah. Function is to note. Prepared. It's all one-to-one stuff. There's I'm going to throw it into the regular equation into the inverse equation real quick. See what we got out of that.
Bless you.
Thank you. 1 equals minus 5 x minus 7 plus 5 minus 7 over x minus 7 5 plus 1 12 plus 5x 5
Because I found it says like using coefficients to verify an inverse function. So to verify, we do kind of what we're doing, but it doesn't equal 1 or negative 1 or 1, like the goal's not 1, the goal is x.
Yeah. That sucks. Should I give us the answers review?
No, no. There are no answers to this exam review. Unless if you want them. We will make one for you then. Well. Oh. Well, first one in 13A. 13A is universally.
It's what?
It has an inverse and it's like universal
Oh, really?
because it comes out to x.
Would you have the inverse on that? Minus x minus 21 over minus 3? Or is that all
No,
just
the
equal?
inverse. So the function is 3x minus 21, and the inverse is x plus 21 over 3. Because you substitute in the y, so it's 3y minus 21 equals x, and solve for y, which then becomes, through various steps, x plus 21 minus over 3.
Yeah.
So then, to put that back in, you put the inverse into the original, so then it becomes like 3 by the inverse minus 21, and all the other things cancel out. And it just leaves x. So,
We just happen to choose the two that were not.
right. Right. Good job.
Hey, if you could come get me, that'd be great. Because cartridge just shot me off. So. On Second East, I think. You know that four-way stop that's right before you turn to go to Kimball? You know that four-way stop on Second East where you turn to go to the Kimball? So I am down the hill from that, probably a quarter mile. When you're on your way, just let me know and I can be outside. Okay, sounds good. Bye. Okay. So just to make sure I know how to throw stuff back in the equation. So we got 3x plus 21 over 3 minus 21. So the 3's cancel out on that.
Yeah. Because it's pretty much 3 over 1.
Yeah. Yeah, so just see what happens.
Yeah.
And then you throw it back into the inverse.
No. So like 3.
Like 3x minus 21 plus 21. Wait. I just got confused.
There's no x's. Wait, is there? What did I do wrong?
The inverse, yeah, it was x plus 21. 3x plus 21 over 3. No.
Oh, there it is. Yeah, so then still the 3's cancel out and then everything. And then x.
Okay. We know it's possible. That's the important thing. Just these stupid ones are in fractions suck.
Yeah. Yeah, they do.
Hope we're doing those ones right.
Yeah, me too.
We haven't found the inverse yet.
Nope.
Even on the quiz, did you find inverse for it? Individual quiz last week we had.
No, I don't think so. I didn't do my best. I had to like quickly do it before going to work, so I was just like, all right, I'm gonna just put numbers down.
I didn't turn it in. So.
Well,
You're ahead of me on that one. Because I was doing homework all day that day.
dude, it sucks just having like all your hours on, all your free time, just doing schoolwork and everything, and then the next thing you do is going to work, and then you come home and you just more homework, but you're just too tired to, so you sleep.
Yeah. Exactly. Well, I guess We can end this YouTube thing.
Yeah, good job. See you next time.
Where'd it go?